Negative properties. So in this module, I will introduce you with a very important term, azeotropes. So let us see that first. So when I say azeotropes, some solution exhibit large deviation from Raoult's law. May it be negative deviation or a positive deviation, but quite large. So the vapor pressure composition curve for such solutions will always exist with a maxima or a minima value when we draw the curve. So next, the vapor liquid line converges at a particular composition. So let me draw that vapor pressure composition curve. So here you would see this is the vapor pressure composition curve. So and this is the liquid composition curve with a negative deviation. So as I said, it is exhibiting quite a large of negative deviation, and this is the vapor composition. So now here, if at all, you would see both of them are converging at a point, and at this point there will always have a constant boiling mixture. That means the mole fraction composition in liquid as well as in vapor will always be same, and that is when we call them as azeotropes. Let me be more elaborative about this. So first, let me take this particular curve, and at a point A you will see the total pressure at point A. Now let the liquid composition be X. So on red curve you would see that is the total pressure point, and X is the composition in liquid state. And as we draw a horizontal line, which is the vapor liquid equilibrium as we learned earlier, now you would get at point B we get a corresponding vapor composition, and let me call that as Y. Now on boiling the liquid solution with composition X, we would achieve that there is a different composition of the solvent, right, in vapor as Y. So the composition is different in liquid state as well as in the vapor state. So that is evident from the curve. So now let me reach to the point C here. So at point C, let me take this as the new total pressure. So if I take that as the new total pressure, that Y will become the new composition X, right? So this will be the new composition X. So again, when I draw a vapor liquid equilibrium line, it touches at point D, and as you go down, because it is at touching the vapor curve, so that Y will be the again vapor composition. You would see certain difference in X and Y again, but do you observe something, that the difference between that X and Y is always decreasing as it is coming closer to this particular point. So let me tell you that every point vapor liquid composition is different but tending to become closer, and it is becoming equal at point O. So this is the point where you would see there is no difference in X and Y. That means the composition in the liquid as well as in the vapor state would be same. So when an azeotrope boils, there is no change in the composition. That is what you see, that the vapor has the same composition as that of a liquid only at one point, and this point where X is equal to Y is what we call it as a azeotropic composition. So, and these kind of solutions where there will be at least one point where X is equal to Y is called as azeotrope. So